All right. You better be happy that you got a good math teacher because I just made this entire video and went to go pause it and edit it. And for some reason, 16 seconds into the video, I paused the video for some reason or stopped recording. And so instead of having a 20-minute video, I had a 16-second video. And so now I'm recording this all over again. All right. Well, at least I know what I'm doing now. So for number 24, we're going to use the quadratic formula to solve this equation. So remember, when you go to solve an equation using the quadratic formula, you must always have it equal to 0. So we're going to start by adding 15 to both sides. All right, so now we have this equal to 0. So now we can use the quadratic formula. So to use a quadratic formula, remember it's x equals the opposite of b, so it's 4, plus or minus the square root of b squared, so 16, minus 4 times a, which is 6, times c, which is 10, all over 2a. So 2 times 6 would give me 12. And what we're going to do is we're going to start with what's under the square root. We call that the discriminant. So if you take 16 minus 4 times 6 times 10, when you do that, you end up getting negative 224 as your answer. So now that's kind of ugly because we have a square root of a negative number. And if you recall, we can't take the square root of a negative number. So what we've got to do is we got to factor out an I, your imaginary number there, and that makes it so we have the square root of a positive number. Now the square root of 224, that's the same as 16 times 14. I might say, well, how did you get that? Well, what I did is I just looked at my list of perfect squares. So 4 is a perfect square because 2 squared is 4. 9 is a perfect square because 3 squared is 9, and so on. And so I tried some of the larger ones because 5 squared is 25. And I tried, 224 doesn't end in 5, so I know that it's not divisible by 225. It's a little trick you can learn. So I started with 16. And I took 224 divided by 16. And when I did that, it gave me 14 as my answer. And 14, the only factors of 14 are 2 and 7. So I know that I can't do anything more with the 14. And the square root of 16 is 4. So I know that that's going to simplify to be 4 times the square root of 14. The other way you could do this, you could do a factor tree, but and find two numbers that multiply together to be 224 and continue going from there, and you'd get the same result of 4 times the square root of 14. All right, so now let's put that back in here. So we have 4 plus or minus 4i times the square root of 14, all divided by 12. And what I noticed there is that all of those pieces, except for the 14, we ignore the 14. So I'm talking about every other piece. Ignore the 14 for right now. But the 4s and the 12 are all divisible by 4. So I'm going to divide those outside pieces by 4. Well, again, we leave what's under the square root. That we can't touch. So when we do that, I'm left with 1 plus or minus 1i, which I'm just going to write as I. Square root of 14 over, and 12 divided by 4, don't forget that, is 3. So that would be my solution for number 24. 25. Write the following in vertex form, then identify the vertex and axis of symmetry. I'm actually going to start with the vertex. So the vertex, remember that's a coordinate HK. And we find H by doing the opposite of B over 2A. Well, in this case, B is negative 16 already, so it's the opposite of that would be a positive 16. So then we take 2 times A. Well, A is negative 2. 2 times negative 2 is negative 4. So our vertex has an H value or an X value of negative 4. So now we've got to figure out, well, what's the Y value? Remember, anytime we know the X, to find the Y, we just plug it in. Or what I like to say is to find K, we just plug whatever H is into the function. All right, so we'll have negative 2 times, so I'm going to put negative 4 in for X. It'll be negative 4 squared minus 16 times negative 4 minus 31. And if you simplify that, you end up getting 1 as your answer. So our vertex is a coordinate negative 4, 1. And then the axis of symmetry, that's always just x equals whatever h is. Okay, so since h is negative 4, it's x equals negative 4. So that's your vertex and axis of symmetry. Oh, so to get it in vertex form, so to go back to that piece, so to write it in vertex form, remember it's y equals our a value times x minus h squared plus k. So we're just going to plug everything in. Our a value is -2, and it's going to be x minus h, so that would be x plus 4, because x minus -4 would be x plus 4, don't forget your square, and then plus our k value, so plus 1. So that would be your vertex form. All right, so this one, I'll just give you this hint on the final. If there's a question like this on the final, I will give you the height of the object formula. So I'll give you that general formula just like this one would be worded. So you don't have to worry about wasting space and writing down that formula in your notes. I will give you this. Now, if you don't know what the v sub 0 and s sub 0 represents, that you might want to write down in your notes. But here it says, so that formula gives the height of an object tossed upward, where v sub 0 represents the initial velocity, and s sub 0 represents the initial height, and t represents your time. So a ball is hit straight up from the ground level with an initial velocity of 72 feet per second. Find the number of seconds it takes to reach the maximum height the ball reaches, and we always also want to figure out what is the maximum height the ball reaches. And we're going to show you work algebraically. The reason why, remember on your final, you cannot use your graphing calculator. So we're going to have to do this using algebra. It's actually not that difficult. You just need to understand what we're looking for. So first, let's write the equation. So it's going to be h of t equals -16 times t squared plus that initial velocity, which is 72 feet per second. We're just going to use the 72. The feet per second we don't use, but it'd be 72t, plus our initial height. Now, if it's being thrown from ground level, that means your initial height is 0. If it says it's being hit off a deck that was 4 feet above the ground or 12 feet above the ground, whatever that would be, you put that in as your initial height, your s sub 0. So the ground level would be that from the ground 0. All right, so when it says we're trying to find the maximum height and the time it takes to reach maximum height, let's think about what we're trying to find here. So if it's being hit from ground level, this represents not necessarily the trajectory of the ball, but the trajectory over time, where it's going technically straight up and coming back down again. So this doesn't represent the distance, it represents the x-axis represents the time since it's been hit, and the y-axis represents the height after that period of time. So your vertex would be here, so that's going to be, so the x would represent the x part of your time, and the y would represent the height. So to find the t, remember we do the opposite of b over 2a. So that's the h, or the x part of your vertex. I don't want to call it h here because then you get confused with the height. So it's, remember when we talk about the vertex being h and k, it's not meant to confuse you. The h is just a special value we use for the x-axis. In this case, our x-axis represents time and our y value represents height, so we don't want to confuse you. So, but regardless, it's going to be the opposite of b over 2a. So -72 over 2 times a, so that's -32. When you divide those, you get 2 1/4, 2.25. So it takes 2.25 seconds for it to reach that maximum height. Now we got to figure out what is the maximum height after 2.25 seconds. So to find the height, we're just going to plug that into the function. So we're going to, every time we see an t, we're going to put 2.25 in. If we had to add something else, we'd add something else here, but adding 0 doesn't change anything. So if I type that in your calculator, you get 81 as your answer. So 81 feet would be the maximum height it would reach after 2.25 seconds. All right, 27. Find all the zeros, both real and non-real of the function. They give us this hint of checking for the GCF. So I'm going to start by factoring this down. So otherwise, if I don't have a graphing calculator, I don't have a way to find all these zeros. So that's why, again, can't use a graphing calculator on the final. So I'm showing you how you can do all of this using just simple algebra. So we're going to start by factoring out an x squared. That's the greatest common factor. Now, if I could factor this down further, what's in parentheses, that would be really great, but I can't. So I have to use a quadratic formula. But just know, always look to see if you can factor it first, because if you can, it's going to save you a lot of time. And for some of you guys, time will be of the essence during that final. All right, so since we can't factor, if you're wondering, how do I know it doesn't factor? Well, there's no two factors of 23 that add up to be -10, because the only factors of 23 are 1 and 23. And there's no way I can manipulate 1 and 23 to get -10. So we're going to have to use a quadratic formula for this piece. So the quadratic formula is the opposite of b, so the opposite of negative 10 is a positive 10, plus or minus the square root of b squared, which would be 100, minus 4 times a, which is 1, times c, which is 23, and all of that is divisible by 2. And if you simplify what's under the radical next, you just get 8. Now we want to make sure that what's under the radical, we want to see if that can be simplified at all. Remember, square root of 8, that's equivalent to 4 times 2, and 4 is a perfect square. So again, to simplify this, look for a perfect square. There's only one to try because 2 squared is 4, 3 squared is 9, and clearly 8 is smaller than 9. So 4 times 2, that works, and the square root of 4 would just be 2. So this would be 2 square root of 2 is what that simplifies to be. And now all of that is divisible by 2. So we're left with 5 plus or minus 1 square root of 2. So those are 2 of the zeros. Okay, but remember, we're going to have 4 of them. Our degree is 4, so that means technically I have 4 zeros. Well, that's 2 of them. What are the other 2? Well, we can take that x squared, set that equal to 0. So I would just get, if I take the square root of both sides, I get 0, but that means I have a multiplicity of 2. It didn't ask for multiplicities, but if you're wondering where the other 2 zeros are, we have a multiplicity there of 0, or 0 is a multiplicity of 2, so that's where the other 2 would be. So we have 2 there, and then the other 2, 5 plus square root of 2, and 5 minus the square root of 2. So those are all of your zeros for that function. All right, 28. We want to use the remainder theorem to find the remainder when that polynomial is divided by x minus 6. Now, there's a couple ways you could do that. You could do that using synthetic division, which I'm not going to do because it's not asking us to figure out what the answer would be. It's just asking us to find out what the value of the remainder would be. So we can use the remainder theorem. The remainder theorem uses the 0 and plugs that in for x. The 0 here is 6 because 6 minus 6 is 0. So don't use negative 6. Use the 0. If you set that equal to 0 and solve it, you get 6. Or you can just clearly see 6 minus 6 is 0. So plug 6 in for x. And when you do that, you end up getting 28 as your answer. So that would be the remainder. So if you divided that polynomial by x minus 6, you would get 28 as a remainder. So for 29, they're not asking for what the remainder would be. It's asking us to actually divide. And so we can use synthetic division for this one, or you can use long division. Okay, but we can't use the remainder theorem because that doesn't give us the quadratic that we would need. All right, so the 0 here would be a positive 2. So you start with that 0 in the little box, and then write the coefficients. So we'd have a 1. So make sure all the terms are represented. We have a 3, 2, 1, and then no variables. So all of them are represented, so I'm just going to steal the coefficients for right now. So we'd have 1, 3, negative 8, and positive 7. Put that little basket underneath the 7 to catch your remainder. All right, so bring down the 1. Then we multiply. 2 times 1 is 2. Then we add. 3 plus 2 is 5. Then we multiply. 2 times 5 is 10. Then we add. Negative 8 plus 2 is 2. Then we multiply. 2 times 2 is 4. And then we add, and we get a remainder of 11. So this one's going to have a remainder of 11, but we also want to write down what the quadratic would be. So remember, this stays a constant. The 2 stays a constant. We put an x and then an x squared. So the polynomial would be x squared plus 5x plus 2 with the remainder of 11. Or we can say 11 over x minus 2. Might want to be familiar with both. It'd be multiple choice. So both of those would be correct. So just saying the remainder is 11 or saying plus 11 over what we divided by x minus 2. All right, so this one's saying, yeah, let's go ahead and use synthetic division for this one again. So this time our 0 is negative 2. Before we do the coefficients, make sure they're all represented. Because remember, if one's missing, we just have to put a 0 in there to hold that position. So 3, 2, 1, none. All of the degrees are represented. So we're just going to use those coefficients, which are 3, negative 2, positive 5, negative 3. Put our basket down there to catch our remainder. Let's go through that process again. Bring down the 3. Negative 2 times 3 is negative 6. Add those together. Negative 2 plus a negative 6 is negative 8. Multiply. Negative 2 times negative 8 is 16. Add those together. We get 21. Multiply. Negative 21 times, or negative 2 times 21 is negative 42. And then we add, and we get negative 45. So again, putting in our variables. So the 21 stays a constant, and then going to the left, we get x and x squared. So we have 3x squared minus 8x plus 21. Again, we could say that the remainder is negative 45, or we can say minus 45, because it was negative 45, over what we divided by x plus 2. By the way, if it asks, is x plus 2 a factor of the numerator, your answer would be no, because you have a remainder. All right, 31. Remember our P's and Q's. Now don't get them confused, because if it's being that it's a multiple choice test, chances are there's going to be the common mistake of messing up which value is your P and which value is your Q. So just remember, your constant at the end is your P, the number at the beginning is your Q. So let's start with 6. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, because 1 times 6 is 6 and 2 times 3 is 6. Well, remember, we need the negatives in there as well, because negative 1 times negative 6 is also 6. So by including the negatives, we have all the possible factors of 6. Now let's look at the factors of, the factors of 2. Plus or minus 1, plus or minus 2. So now we're going to write the ratios, represent these as a ratio of P over Q, and all the possibilities here. So we'd have, I'm going to start with 1 in the denominator. So we'd have 1 over 1, which is just 1. 2 over 1, which is just 2. 3 over 1, which is obviously just 3. And 6 over 1, which is just 6. So those all have 1 in the denominator. Now let's move to having 2 in the denominator. So it'll be plus or minus 1/2. Now 2 over 2 is the same as 1. We already have it. Don't need it again. And then we'd have plus or minus 3 over 2, or 3/2. But 6 over 2 is 3. We already got it. Don't need to list it again. So these are all the possible rational roots. We don't have to do anything with those. Just list them out. All right, so this one, it's talking about the end behavior of this polynomial. And so for this one, remember, look to see first if the leading term is positive or negative. It's negative, so that tells me that the right side of the graph is going to go down. So the sign tells us what's happening with the right side of the graph. If it's positive, the right side of the graph goes up. If it's negative, the right side of the graph goes down. And then the degree tells us what's happening on the left side. If it's an odd degree, it's going to go in the opposite direction. If it's an even exponent, if it's an even degree, it's going to go in the same direction. So I know that the left side is going to go up, the right side is going to go down. So the limit, so let's start with as x approaches infinity for the function, it's going down. So the right side of the graph is going down. That's what x approaches infinity would be, the right side of the graph. Then the left side of the graph is going up, so it's approaching positive infinity. By the way, if it also asks what's a y-intercept, the y-intercept is your c value. So the y-intercept, be where x is 0, y is negative 8. Because if you put 0 in there for x, all those other x's would wipe themselves out, leaving us with just negative 8. So when x is 0, y is negative 8. That's your y-intercept. They didn't ask for that, but you just might want to remember that for the final. All right, so this one's asking us to find the zeros with their multiplicities and then sketch a graph. All right, so to find the zeros, we're going to set each factor equal to 0 and solve. We'll come back to the multiplicities after we find each of these zeros. So to find the zeros here, I would add 5 and divide by 2. Or just subtract 4. Here I would just add 5. So those are our zeros. Now let's figure out the multiplicities. So this has a multiplicity of 2 because it's being squared. This one has a multiplicity of 3 because that one's being cubed. So we have 3 of the same one there. And this one has a multiplicity, try to fix that, of 1 because we only have 1 there. So if you add those together, we have 2 of these, 3 of these, 1 of these, so that's a total of 6. So we'd have 6 zeros, just that some of those include multiplicities. All right, so it says find the zeros and their multiplicities and graph the polynomial. Okay, so to figure out what the end behavior is, because that's what we're going to need in order to graph it, I'm just going to take each leading term in parentheses along with its exponent. So x is cubed and x the first. So we're going to have 2x being squared times x being cubed times x to the first. So then you're going to take, when you square 2, you get 4. So this would be 4x squared times x cubed times x. So when you multiply and the variables are the same, remember you add the exponent. So you'd end up with 4x to the 6. So that tells me for my end behavior, the fact that it's positive, the right side goes up. Since it's an even exponent, the left side is going to go in the same direction. If it was negative, remember the right side would go down. Or if it was an odd exponent, the left side would go in the opposite direction. So now I have enough information to sketch a graph. So I'm going to have an x-intercept at -4. We'd have an x-intercept at 5 halves, which is 2.5. And we have an x-intercept at 5. Now I also know from my end behavior that the right side is going to go up, the left side is going to go up. Oh, we also need to describe the end behavior at each zero. I forgot to do that. Since there's a multiplicity of 2 here, it's going to bounce. Since this one has an odd multiplicity, it's going to pass through. So same with this one. It's going to pass through. So that's going to help us with our graph here. So I know it's going to pass through -4. Then it's going to bounce off 5 halves. And then it's going to bounce off that, and then it's going to pass through that one again. So now we got our graph. It might not look exactly like that, but that's at least the general shape. That's all we need to worry about. All right, so that is the end of Chapter 2, Part 1.